Hello, good afternoon. Okay, so we're on to our last module. Let me bring up our schedule here. We are here on October 26th. Your homework 6 is due tonight. And this week we'll talk about abstract classes and interfaces. And that should only take actually today's lecture. So Wednesday's lecture will be office hours, and then Friday will be project discussion. And even for the project discussion, that's basically Q&A, not a lecture style. I'm not planning on a lecture style for that. And after that, we're moving into the module on data structures and algorithms, which is, I'm not planning any live lectures for that. These are going to be topics that may be helpful for you in creating your project because they give you ideas about how to structure your data and how to develop algorithms. But there's no explicit assignments or testing that goes along with that. And so the idea is towards the end of the semester to just turn you loose and let you work on your projects and have you focus on your project work and try to scale back the amount of deliverables that are required other than the project deliverables. So you're almost done with your labs. You're almost done with your homeworks, getting close to it. And so the weekly grind should start to slow down a little bit so that you can work on projects. And then you may have noticed I've opened up your project discussion groups. So if we go here under assignments, this is the last week for a quiz. And under the projects, I've done the 4.1, 5.1, 6.1, there you are. And 4.1 is available now. So the discussion groups, the way we did it last time, I think worked out fairly well. There were some issues with timing, which was basically my fault. And so for the 4.1, the timing constraints are a lot looser. You do not need to upload your work until you actually upload it for the P4 deliverable. I encourage you to do so ahead of time to get feedback from your group mates. And the responses are not due till a week after. So it's not so closely tied to the deliverable. As soon as 4.1 closes, 5.1 will open. And as soon as 5.1 closes, 6.1 will open. What I hope is that you come to rely on your group mates and get involved in some good discussions there and not just upload your work when you deliver it to me, but upload it periodically and ask questions. If you're having trouble, this is another resource that you can go to get help. You can also start to compare coding styles, solutions, things like that. As far as resources, when you're having troubles, obviously go to Dean or myself or the, Robert Apelian, Michael Fornito, your lab TAs and tutors. If you guys have questions or comments, just jump on in. All right, so module 10 outcomes. This is pretty straightforward stuff. It's the last of the items that we take out of the text. Abstract methods. Let's talk about abstract methods first. An abstract method is basically, it's a method signature with no body. There are no executable instructions. Normally, if you put a signature in without a body and try to compile it, the compiler will say, hey, you didn't fully define this method. If you put the keyword abstract in there, then the compiler knows not to look for the body of the method. So you would say, as in down here, public abstract return type, and then the name of the method. Now, why would you do that? We've talked about this earlier in the semester when we were talking about inheritance. I had a generic shape, and then I did a circle and a rectangle and a square, and we had methods in the generic shape like calculate area, but you can't calculate the area for a generic shape. So there's no point in doing it. So this gives you an actual mechanism to get away with that. I mentioned that earlier, but I didn't, it wasn't time to introduce this mechanism just yet. So you have the mechanism now to define a method signature without being required to put a method body in there. And when we get to abstract classes, well, here we are at abstract classes. We can talk about why you would want to do that. Classes are the same way. If you want to have an abstract class, you use the abstract keyword. So instead of public class animal, this is abstract class animal. Now it should have been, in my opinion, public abstract class animal, but abstract class animal. The method sound only has the signature, public abstract string sound. It only has the signature, not the method body. If you have an abstract method in a class, that class absolutely must be abstract. No way around it. So that's how you know when to make abstract classes. So if you have the abstract method, must be an abstract class. Now that class may contain attributes, that's fine. And it may also contain fully defined methods, that's fine. The rule is if one of the methods is abstract, one or more, then the class itself is abstract. And you cannot instantiate that class. You cannot say abstract class object equals new abstract class to make an object of that type of that class. You can't do it. Why? Well, think about it. If you tried to create an object of that class and then use the method, what is the Java virtual machine going to do? It doesn't know how to do anything with that because you haven't instructed it. So you are not allowed to create objects out of the abstract class. You are allowed to use inheritance. So you can have abstract classes with concrete children or fully defined children. You can have abstract classes even with abstract children. If the children are abstract, they are not on the hook for defining those methods that are abstract. If the children are not abstract, they have to define every method. You can have actually parents that are fully defined and then have abstract children, but that's kind of a weird thing. So pretty flexible on that stuff. Now, why would you do this? So remember again, earlier I did the generic shape and then the circle and the rectangle and the square. And we had that calculate area, calculate perimeter methods in there. And I was saying all along that it's silly to define these methods. So, but I had to put something in there. So I was giving back, bad data with a warning message is what I was doing. So now what you can do is get away from that and just have the abstract method signature. And again, why would you do that? Well, if you think about how object-oriented paradigm works and how it works specifically with inheritance, you create this generic thing, and then you create more specific versions of that thing that are the children, right? You extend it to create the more specific things. So we have a generic ship, but then we extend it to rowboat, tugboat, oil tanker, whatever. By including the method signature as an abstract method in the higher level generic class, you are guaranteeing that all of the children will not only have that method, but that the signature is the same for each one. Now that may not seem like a big deal because all of us are going to say, oh, if I was creating that class, I'm sure I would do the signature the same in all the different classes. Well, as a human being, we're not built that way. We're built to have minor variations on a theme. Let me show you an example. Look at the quizzes. M00.3 space quiz, M03.3 hyphen quiz. I don't know why I did it that way, other than I did them several weeks apart. That's how we're built. We're not good at repetition. So what you're doing with the abstract classes is you're guaranteeing that all the children will have the same method signatures, the same input parameters, the same return types. Now, because you haven't defined the body of the method, each child can have different behavior, which is exactly what inheritance is all about. What that means is you can build all the code out at the higher level, at that abstract generic level, and it will work. Because remember, inheritance is about an is-a relationship. So a circle is a generic shape. So if I make methods that work for generic shapes, they'll work for circles, and they'll work for rectangles. And if someday I want to add a pentagon to that list, it'll work for pentagons. So you're actually enforcing consistency among the child classes, and you're allowing for consistency for classes that maybe you haven't even thought of yet, that you haven't even invented yet. In my sheep-sheepdog game, I've got a sheep and I've got sheepdog. I have that generic animal, and then sheep extends generic animal, sheepdog extends generic animal. Well, maybe next year I say, yeah, I'm going to add a wolf. Now the dog has to protect the sheep from the wolf. That's a class I hadn't even thought of when I started making that game, but I can just extend animal and have the wolf. And because the animal, the generic animal, has a move method, the wolf will have a move method. And if I do it this way using abstract classes, the move method will work. Now, that doesn't mean the logic got right. It means that the connections will all work out. The expectations as to the return type and the input parameter list will work out. So that's why we do these things. A closely related entity from an abstract class is an interface. An interface is much more restricted than a class, than an abstract class. The interface may only have abstract methods. So the abstract class could have fully defined concrete methods and abstract methods. The interface may only have abstract methods. And the interface, if it has any attributes at all, and often they don't, they must be constant value attributes, constants. So the abstract class can have any kind of attribute. The interface can only have constants. Why do you do this? Why would you have an interface? What's its job? Well, its job is to be an interface. What's an interface? An interface is a meeting point between two things. When I worked at many years ago, McDonnell Douglas Aerospace, and we had avionics boxes, and we had to bolt these avionics boxes to a bulkhead. And that meant, you know, the avionics box has these little feet on them, put bolts through, screw the bolts in. Miraculously, the holes for the avionics box lined up with the holes in the bulkhead. That was not a coincidence. That was not an accident. We had something called an interface control document. And we said, we're going to make our bolt hole pattern look like this, and you better make your bolt hole pattern look the same, or this box won't work. Everything you do in the physical engineering works that way. You have two parts that go together. Well, they better line up, right? The holes for the bolts better line up, or for the rivets. They better have the same shape. These are interface control documents. That's what they're for. It works for physical things. You've probably built, bought, furniture that you need to assemble at home, or a grill that you need to assemble at home, or something like that. And you can tell how good a job they did about how easy it went together. Sometimes the holes line up really well, sometimes not so much. That tells you how good their quality control is. The same thing is true for software. Same thing for physical items as for software. And you know this because here we are on the internet. My computer is sending signals to a server somewhere. That server is sending signals to your computer. My computer and that server were built in different years by different companies, and your computer built by different year, different company, and yet it all plays together. How is that possible? Well, it's not an accident. We're using Internet Protocol. Internet Protocol is basically an interface. Internet Protocol describes all the rules for moving data around on the web. And people got together over years and they sat in a room and banged the table and argued with one another and came up with this document that defined how you move data around on the web. Even if you're designing your own software system and you have to interface with another software system, you may have to come up with an interface control document. We're going to send you packets of 1024 bits. We're going to do it at most once a second. And the first 16 bits are a timestamp, and the next 16 bits are a message ID, and the next 16 bits are 32 bits are an IP address, and the remaining bits are the message. Something like that. Maybe the last 8 bits are a parity check or something like that. But you literally say every bit in this data stream is defined. It has a job to do so that when the other side receives it, they can take that and interpret it. That's the generic notion of an interface. In Java, an interface is, as I said, it's a series of abstract methods, and maybe some constant attribute values. And you use it in the same way that you use an interface anywhere else. You're creating software. Someday someone else is going to build some software that relates to yours or uses yours or expands upon yours. And in order for their software and your software to work together, everybody has to be speaking the same language. So basically what you're putting out there is, hey, if you want to use my software, you have to implement this interface. Here's 6 methods that you must have, and you have to match their signatures exactly, inputs and output types. You probably will not need or use an interface in your project. You have every reason to use an abstract class in your project because I'm requiring inheritance, and you probably don't want to actually instantiate the generic version of whatever you're making. But interfaces are more about larger projects where you have multiple teams involved or multiple corporations involved, whereas in this class, you're one person working on your project. So you probably don't need to interface with yourself. Now, if you're making a product that you intend other people to use, you may have an interface hanging out there for other people to build off of. In inheritance, we say one class extends another. For interfaces, we say one class implements the interface. So author's example, public interface edible, and then they have the abstract method, how to eat, and then abstract class fruit implements edible. Now, unfortunately, this is the best example because the class fruit did not fully define the method, how to eat. But that's because the class fruit is also abstract, so it's allowed to have abstract methods in it. One last point, and then we'll start doing the code examples. You can both extend and implement. Now, in Java, we have what's called single inheritance. You can only extend one class at a time. So if you think in terms of parent-child relationship, the child can only have one parent. It can only extend one class. Other languages allow what's called multiple inheritance, where you can extend multiple classes, but not Java. This is the closest we get to multiple inheritance. You can both extend a class and implement an interface. So in this case, the author's example, class chicken extends animal implements interface. Now, since chicken is not abstract, it has to fully define all the methods. And the method it got from edible was how to eat, so they just defined it as returning that string. And the method they got from animal was sound, and so they define it as returning that string. Before I go to the code examples, are there questions? Okay, so here's the geometric object. which is an abstract class. And they have a bunch of junk in here. By the way, this color is not the same color as what we talked about with Java FX. This is completely made up. It's just a string, right? It's not a real color. In Java FX, if you recall, color was an object, right? They're just playing around with strings. And they have some methods that are defined. And then they have down here 2 methods that are abstract. They are not defined. So again, this generic geometric object, there's no way you would know how to calculate the area for it or the perimeter for it. So they don't define those methods. But every specific shape you make that extends geometric object, you're guaranteed now not only to have a get area and a get perimeter method, they're named the same, their input parameter list is the same, and their output is the same data type. So in terms of software development and maintenance, you're not allowing people to make so many mistakes. And sure enough, if we look at circle, circle extends geometric object, and then down here, they finally define get perimeter, and they define get area. Notice they had to override the original empty methods. Same thing with rectangle. Where is it? There it is. Get area, get perimeter. They define it specifically for the rectangle. And then all they do for test geometric object is, they run the test, right? So if I do, whoops. 2 objects do not have the same area. The circle has an area of 78 point whatever. The perimeter is 31 point whatever. And the area of the rectangle is 15, perimeter 16. Let's look at how they built that file, though. That's more important than the actual running. If you look at how they declared the circle and the rectangle, they call one object 1 and one object 2. The data type when they're declaring is geometric object. In other words, the higher level. Right? Geometric object is the generic version. Circle extends it. Rectangle extends it. They're at the higher level. Now, you're not allowed to create an object of geometric object class because it's abstract. But what do? They create a new circle and they create a new rectangle. How can they do that? Well, they can do that because remember, inheritance is a relationship. A circle is a geometric object. A rectangle is a geometric object. And then when they define the method for checking to see if these two shapes or geometric objects have equal area, the input to that is geometric object, not circle, not rectangle. It's geometric object. Well, what does that mean? It means it works for circles, and it works for rectangles, and it works for any combination of circles and rectangles. There's a lot of value in this. This is one of the strengths of the object-oriented paradigm. This use of inheritance, defining your methods up at the higher generic level, even though you will never create an object of that generic type, of that generic class. If you define all the methods at that higher level, then all the children work. So here we have, again, displaying the stats for the geometric object. It's at the geometric object level, not the circle, not the square. And then they do this object get area, get perimeter. How do they know there is such a thing as get area, get perimeter? Well, because in the abstract class, get area was included as an abstract method. Therefore, if circle is going to extend that class, it has to define get area. Get perimeter was included as an abstract method at the generic level. So if circle is going to extend it, it has to define get perimeter. What you're enforcing is code consistency. You're also making this larger software framework work regardless of the the specific type of the children, as long as they're extensions of that generic type. Notice they only gave us a circle and a rectangle. What if we wanted to add a pentagon? What if we wanted to add an ellipse? We can do that, and it will still work. So this top level test geometric object method, all these things here, it will work even for things that we haven't invented yet. There's a lot of strength there and a lot of flexibility there. Okay, the other example, and these are on Canvas right now. The other example is for an interface and also for extending abstract classes. So here's the interface. Now notice it's not public class editable, it's public interface editable. And as soon as you declare that something is an interface, it's only allowed to have abstract methods, and it may have constant attributes. So they only put in one abstract method because, you know, it's an example. If you have a class that implements this interface and the class is not abstract, you must define every method in the interface. You can't just do some of them. It's a contract, and you have to fulfill the contract. You're saying, okay, I volunteer to implement this interface. What you're volunteering for is to implement every method. And here, test editable. Now, you know, the authors did a very bad thing. That's the entire class. That's the entire test editable class right there. What are all these other things? Well, these other things are other classes that they embedded in the same file, which you should never, ever, ever do. Animal should be in its own animal.java file. Chicken should be in its own chicken.java file. But oh well. So they wrote this abstract class animal, and all it has is this one abstract method for sound. And then, let me see here. Initially, well, I've changed the code a little bit from how it was. Chicken extends animal and implements editable. Since it extends animal, now chicken is not an abstract class. It's not allowed to have any abstract methods in it. Since it extends animal and animal had an abstract method, sound, then you have to define sound. And since it implements edible, and edible had the one abstract method in it, how to eat, you have to define it. Similarly, the original version of this that you have online, the tiger extends animal, but it does not implement edible. So since it only extended animal, it only needed to do sound. And then I added implements edible, so then you have to define how to eat. Fruit does kind of an odd thing. Fruit is also edible, so it implements edible, but notice that fruit was an abstract class. They've defined it as an abstract class, so you're not on the hook for defining all the abstract methods yet. However, apple extends fruit, and since fruit contains that abstract method, remember, fruit implements edible. In other words, it contains that abstract method. And since apple extends fruit, it inherits that abstract method, and apple is not abstract, therefore you have to define it. And orange is the same way. And so if we run this thing, no surprise, you just get the output. Okay, so for review, you would use an abstract class if you are having a inheritance situation with a generic base, and then you extend to the specific children, and you know that you will never, ever, ever instantiate that generic base, which, by the way, that's just good design. If you have a generic thing, you should never, as a general rule, you shouldn't design your code in such a way that you would actually implement that or instantiate that. Then you can make that thing abstract. You are never allowed to instantiate abstract classes. Abstract classes may have fully defined methods and abstract methods. Technically, it could have all fully defined methods. If a class has at least one abstract method, it must be an abstract class. Abstract classes are allowed to have attributes just like any other class. Interfaces have more restrictions. They may only have abstract methods and only constant value attributes, which, by the way, you do with private final int x equals 10, something like that. Once you say final, it can't be changed. One last thought. Where was that thought? Oh, there are weird opportunities every now and then where you actually use, without instantiating, you use abstract classes without instantiating them. And the most common one that you've already encountered was the math class. You've used math.py and math.random and probably math.power or so some other, or the trig functions that come from math, the math class. But you never instantiated the math class. You never made a math object. The math class is an abstract class that happens to contain all of these concrete methods for doing useful math work. So there are odd situations sometimes where you actually use the class without instantiating it. And I suspect if we looked at the math class, all those methods would be static so that they could be used, unless the Java machine actually does instantiate an object of that class for you, but I don't believe it does. Okay, that's the whole module. That's all we need. That's why Wednesday will be office hours. If you come to on Wednesday, I'm just going to be sitting here working, waiting for you to ask me questions. But there's no required attendance or anything like that at the office hours. You're welcome to be here and you're welcome to ask questions. Do we have questions today? I think there were some homework questions earlier. None from Evan. Okay. Some people were asking about the homework. Just to clarify, you are not required to do a GUI for your homework that's due tonight. That comes in the let's see, this is homework 6. So you've got 7 and 8. 7, you do the GUI with animation, and then 8, you provide the user interaction, I believe. You do not need a GUI. And correct me if I'm wrong, on homework 6, you have the hare, which just basically does projectile motion. And then you have the hound, and the hound can do this firing of the jets to raise the balloon up some. And last year, people were emailing, freaking out because they were like, oh, I can't make the hound smart. I can't come up with an AI for the hound. And you don't need to. You absolutely don't need to. Because remember, the hound isn't going to be controlled by the computer at the end product. The hound is going to be controlled by the human playing the game at the end. So all you need is a mechanism, a method that will fire off that jet for the hound to raise up its thing, elevate itself. And ultimately, the human will be the one who presses the button or mouse click or whatever to raise it up. All you need is that method. And then if you just want to have the hound randomly, every tick of your loop, just randomly decide whether or not to fire off the fuel, then something like that is fine. But the bottom line is you are not creating an intelligent hound right now, nor will you ever, because ultimately it gets controlled by the human, not by an internal reasoning. I can't remember the requirements. So if the hound follows If the hound has constant downward velocity, then that's correct. It would be, that would be not projectile, but I can't remember the specific requirement from this homework. I thought you had a requirement that it had to be able to fire the heat, you know, the flames to make the balloon rise up, that method had to be there, not that you use it in any intelligent way, but maybe I'm wrong. Maybe Dean changed it from last year.
I had a question about the homework actually.
Yeah.
So there is a requirement which says that the hair has to follow projectile motion, which you just mentioned. It needs an initial angle and an initial velocity, which are both random. But
Right.
then it also says that it needs to update its X position by 10 units every 1.5 seconds. So how does that work? I mean, how can you have both at the same time?
Oh, you're saying that because of the angle and the velocity, the X velocity can't be fixed because it's going to depend on the angle and the velocity.
Yeah.
It says that for the hare, huh? Check with Dean. He might have wanted that for the hound, or does he have a different one from the hound?
Okay.
Right, check with him. Yeah, we had to modify it some because, you know, when he gave the homework assignments last year, he and I worked on it together, but then he published them. And then when he gave them, he did the classic physics projectile motion, which is a closed form solution. And he and I didn't think anything of it. And then students were just having here it is now, and here's the endpoint, but they didn't do a loop where they kept updating the position, which obviously if you're going to play a game, then like Brandon just said, it was a true teleportation. You know, the hair is here and then it ends up there. Well, there was no animation to do it, right? So he did rework it a little bit to get people in the mindset of, no, you're going to go through a loop and you're going to have like a delta Y, delta X every time through the loop earlier on, so that you would be ready to make an animation when it came time for that. It might be, yeah, check with him on that. He might have that in there in terms of how the animation flows, so that some people had an animation that was like, which is not a good game. So he might have that in there strictly for animation, not for the actual movement of the model. You know, we've got view and model, right? So check and make sure that's not a requirement on the view as opposed to the model.
Right, and like you said, there's no GUI in this homework assignment.
That's correct, right. Other questions? All right, guys. Always good to see you. Have a good week. I'll see you Wednesday if you need to be here for office hours. I'll see you Friday for project discussion.